So in this video, we're going to start by practicing factoring out the GCF. And so this might sound familiar. GCF is talking about the greatest common factor. And just to give you kind of a background knowledge, let's say you were asked to figure out what number divides into 8 versus 16, okay? So you're picking out what number divides into both of these, and you would say 2 works because they're both even, 4 works because 4 divided by 8 is 2, and 16 also divides by 4, but also 8 works, right? But when you're asked to find the greatest common factor, you have to pick the biggest factor or the biggest number that divides. In this case, the winner here would have to be 8. 8 is the greatest common factor between both of these. So basically, when you're asked to find the greatest common factor, you're looking for the biggest number that divides into all of the terms. So let's take a look at part A to see if we can do it with variables. When it comes to variables, you want to look at the power. So this x is to the second power, and this x is technically to the first power. So if I were to look at both of them, I notice that both have at least x to the first power, so I can pull out 1x. So I'm going to write an x down here. Now, here's the thing. If I take away one of the x's here, that still means I have 1x left. So what I'm going to do is create parentheses to describe what I have left over. So I have 1x left over here, and there is a minus sign here, so let me drop that down because I didn't take out a minus sign. And then this is the part that gets tricky. So I took out this x, I removed it, right? But that doesn't mean that it's a 0 left over. So when you're factoring something out, you're essentially dividing it off. So if I took out this x and I'm dividing, well, what's x divided by x? It's 1. That means there's still a 1 left over. So let's see if this works. This is what we call the factors because when you multiply them, you should get back to the original expression. So let's just double check by distributing the x. So x times x is x squared. X times -1 is -x. So this does work. And so I've basically factored out all that I can, which is just this x. There's nothing else that's similar between x and 1, so I can't factor anymore. So this is my final answer. Let's practice that some more. So this one here, let's first look at the coefficients in front. This is a 2 and this is a 6. So if I think about it, the number that both divides into 2 and 6 is 2. So they both have a common factor of 2. Now, I also noticed that they both have x's, so that means I can pull out the lowest power of x's, which in this case, this one has x to the first power, so that's the lowest amount that I can pull out. So I can take 1x from here and 1x from here, because I have at least 1x for both of these. Now, if I were to do this, I still have stuff left over, so let's create some parentheses to put what's left over. So for this one here, I took away the 2. So that means I don't have a 2 in front anymore. Now, I also took away one of the x's. So how many x's do I have left? Well, I only have 2 x's left, so x squared is left behind. The plus sign comes down because I didn't take out a plus sign. And with this one here, I took away 2. So if I divide 6 by 2, that means I still have 3 left over. And I also took away this x here. So if I took out the x, that means there's no longer an x here. So in this case, this is my final answer. And let's just double check. If I were to redistribute, 2x times x squared would give me 2x cubed. 2x times 3 is 6x. And so this works. Now, if I were to take a look to see what's on the inside, x squared and 3 don't have anything in common, so I can't factor out any more than what I have left. So this is it. This is my final answer for my factors. All right, let's try something different with more parentheses. So notice how both of these, there are 2 terms here, the first term and the second term, and they both have x minus 5. And so we can treat this as one big factor because it's technically multiplying its thing that it's beside it. So we could technically remove it and factor it out or divide it out. So if I were to do that, that means x minus 5 would come out from both terms. But what do I have left over? Well, I have an x left over here and a 3 left over here. So I'm going to create a new set of parentheses and drop down my x. Now, don't forget that plus sign. And then I'm going to drop down my 3 that's left over from this term. So if I were to take this factor and multiply it into the first term, or x, I would get this first term here. If I were to take x minus 5 and multiply it to 3, I would get this factor here. And so this is going to be my factors, but I can't really factor anything else out from here because x and 3 don't have anything in common. X and 5 don't have anything in common. All right, last one but not least. So this one here is very similar to the last problem. They both have two terms, so one term, second term, and they both have x plus 1. So I know I can factor out x plus 1. If I do, I'm left with this term here, 2x squared, and negative 5. So I'm going to make another set of parentheses and put my 2x squared that was left over, drop down the minus sign, and put down my 5. And from here, if I look at this term, there's nothing I can remove. X and 1 don't have anything in common. And same thing on this side. This one has an x, this one doesn't have an x. So I can't pull anything out. And this is a 2 and this is a 5, and they don't have anything in common either. So this is my factors. And that's it. All right. Now that we've had some practice factoring out the greatest common factor, let's talk about the factoring called grouping. So in the previous lesson, we learned how to factor things that are cubed. So if you look at these problems here, these are cubed or taken to the third power. But they are only two terms. So when you have two terms, you can use the sum and difference of cubes. So this is a formula you can use. But if you don't have two terms and you have more terms, you might want to consider factoring by grouping. So you only use this method if you're given 4 terms. And what you do is group the terms into 2 pairs. And I'll show you how to do it. So once you group them up into 2 pairs, you're able to factor them by doing something similar and factoring out the GCF. All right, let's start with this one here, part A. So we're going to try to factor by grouping because there are 4 terms here. 1, 2, 3, 4. And so what you have to do is split them up into 2 pairs. And to do this, let's start imagining that I'm dividing up this polynomial. I'm going to take these 2 and put them together, and these 2 and put them together. Now, when I do, I can just concentrate on trying to factor out the first set of parentheses. If I look at both of these, the lowest power here is x squared. So I can pull out at least x to the second power. If I do, what do I have left behind? Well, you took 2 away from the exponent, so that means you only have 1 x left, or x to the first power. So I still have x to the first power here. And then this one, you took away the x squared from it, so that means you still have a negative 2 left. So you factored out an x squared, so all you have left is an x and minus 2 inside. Notice if you were to redistribute, x squared times x is x cubed. X squared times negative 2 is negative 2x squared. With this one here, you have a 3 and a 6. They don't have both x's, so you can't factor out an x. But you can factor out a number. 3 and 6, what can they both be divided by? They can both be divided by 3. So drop down the plus sign that's between them and take out a 3, or divide out a 3. So when you do, that means you have just an x left inside, and 6 divided by 3 is 2, so you have a minus 2. By the way, if you notice my language, when I say factor out and when I say divide, they mean the exact same thing. So when you're factoring out a number, you're dividing out a number. So that's like me saying, okay, I notice this is a 3 and this is a 6. What number can they both divide by? They can both divide by 3 is the highest number. So I'm going to divide out 3, or I can say I'm going to factor out a 3, and that's why the 3 is out here. And so from this case, I still have two terms, but I notice that both of them have x minus 2 as a factor. So I can pull that out, x minus 2. But what do I have left over? Well, I have x squared left over in the first term. Bring that down. This plus sign I need to bring down. And this 3 that was in front of the x minus 2 gets pulled down. So from here, I can't factor anymore because this is an x and this is a number. This is an x and this is a number. And so that's it. This is going to be my factor. So this is my final answer, and that's how I factor using grouping. All right, let's try out part B here. So part B, again, has 4 terms. So you start by putting together the first 2 terms and the last 2 terms. Now, here's the thing I want to mention. Oftentimes, it is in order by highest power to lowest power. If it's not, I highly recommend that you put it in order because it will help make the grouping process easier when you group up the highest powers together and the lowest powers together. So with this one here, the lowest power is going to be x squared. So I know I can pull out an x squared. I also noticed there's a 3 and a 12. So 3 and 12 can both be divided by 3. So I pulled out a 3 from here and I pulled out a 3 from here. I have something left over. So in this case, if I took out this 3, nothing is there anymore. It's just a 1. I took out a x squared. So that means there's still 1x left over. I'm going to bring down the plus sign that's between them. I took out a 3 from here as well. And that means I have a 4 now. So 12 divided by 3 is 4. I took out an x squared. So if I took this away, that means there's only an x plus 4 left. So there's only a 4 left here because I took away this x squared. All right, so I'm going to just redraw, move this parentheses just a little bit. All right, so on this side here, you'll notice this time you have a minus sign, and that's the part you want to be careful. So if I'm going to drop down this minus sign, and you guys will start to notice something. Now, we're going to continue like normal. This one has a 2, this one has an 8, so they both can be divided by a 2 is the greatest common factor. And we would bring down our parentheses, but here's the thing. Notice in front of the parentheses, it's a minus 2 that you're factoring out, not just a positive 2. So be very considerate. So if this is the 2 you removed, you have an x, so I'm going to pull that down. That's left over. This one doesn't have an x. This one just has an 8. So 2 divides into 8 4 times. Okay, but here's the thing. This is a negative sign here, and you technically pulled out a negative 2 out because there's a negative 2 to begin with. So that means this needs to be a plus sign instead. And that's just because if there was a negative sign here in front of the number you're factoring out, you are also considering that you'll need to switch the signs that are inside the parentheses. Because if you were to distribute negative 2x times negative 2 times x is negative 2x, negative 2 times 4 is negative 8. And so in order for this to be a negative 8, this needed to turn into a positive sign because you're going to distribute this negative sign if you were to factor that back in or distribute that back in. All right, so from here, notice how both of these terms, 1 and 2, both have x plus 4. So we can factor that out. So x plus 4 gets factored out. What we have left over is 3x squared. This minus 2 in front of the other factor. And that's it. Now, I can't factor these two because x and 4 don't have anything in common. Neither does 3x squared and 2. So this is my final answer. All right, let's try out C here. So C here has all plus signs. This might make it a little bit easier. So let's put them in parentheses. They are already in highest power. Now this first one, they both have 5, so I can pull out a 5. They both have x's, and the lowest amount that I can pull out is x squared. And this one, I pulled out the 5. I pulled out 2 of the x's, so I have 1 x left. I'll bring down the plus sign. I took away one of the 5's, and the x squared. I took out the x squared. So it almost looks like I have nothing left over, but you don't want to put 0 here, because if you put 0 here and you multiply it by 5x squared, you'll get 0. So this would have disappeared. So instead, you want to put 1. And the reason why is because you factored out 5x squared. So you didn't get rid of it, you just divide it off. So if you divide this with this, you get 1. This part here gets a little tricky because this is an x and this is a 1. They don't look like they have anything in common. So I'm just going to bring it down as it is. So when I bring it down, I start to notice, okay, both terms, 1 and 2, both have x plus 1. So I'm going to bring down the x plus 1 as my factor. So I'm factoring out both of these. But I still have something left over. I still have 5x squared. And there's a plus sign, but there's nothing in front of this one this time. But don't be fooled. If you were to factor out the x plus 1 off of each of these, you would take this one away and leave this behind. You would take this one away, but remember, you always leave a 1 behind when you factor. So you would have a 5x squared left over and a plus 1 left over. So there's technically a 1 in front of this factor, even though it's not explicitly written. So be very careful. And that's pretty much it. I can't factor anymore because these two don't have anything in common, and neither do these two. So that is C. All right, let's try out D. So for D here, if I were to group them up, let's put 2 of them together. They're already in highest power of order. The first 2, this one has a 2, this one has a 12. So my highest coefficient here that I can factor out is a 2. So I'm going to take out a 2. My highest power here would have to be an x squared. And so that means I took out this 2 and I took out an x squared. So I have only an x left over because the 2's gone, but an x is still left since I only took out 2 of them. The minus sign drops. I took away 2 from 12, so that gives me 6. I took away the x squared, and so that means only a 6 is left over. So I'm going to scoot this over just a tiny bit more. Bring down the plus sign. So this is a 5 and this is a 30. So they both have a 5 in common that I could divide out or factor out. I'll bring down the x. So I factored out the 5, the x comes down, the minus sign comes down. 30 divided by 5 is 6. Okay, so they both have x minus 6 on both terms. So I can factor out x minus 6 and see what's left over. So I have a 2x squared left over. And the plus sign comes down, also the 5 comes down. And there we go. That is going to be my final answer. All right, I hope you guys found this video helpful. If you have any questions, ask your teacher.